Hey guys, we're back again. Today we're going to talk about Rhombi and Squares. Sounds like the title to a bad cop show. A rhombus is a parallelogram with all four sides congruent. Okay, so if we take a look at this drawing here, segment AB is congruent to segment BD, congruent to segment DC, congruent to segment AC. So rhombuses have all of the properties of a parallelogram, and in addition, two other special characteristics. Yeah, I know I'm going all over the place with this. Each of the diagonals is a perpendicular bisector of the other. So segment AB, let's say we'll call this here, call it X. So segment AX is congruent to segment DX. Segment BX is congruent to segment CX. So both diagonals are perpendicular bisectors of each other. Okay, so segment AD is the perpendicular bisector of segment BC. Segment BC is the perpendicular bisector of segment AD. And all of the rules that go in line with perpendicular bisectors are still in play. So that means, of course, that if, just like we learned before when we talked about perpendicular bisectors, they're equidistant from the endpoints of the segments. So on with this, and we'll talk now about squares. So a square is a parallelogram with four congruent sides and four right angles. So a square is both a rectangle and a rhombus. So all of the rules of rectangles hold true. So number one rule we got from rectangles the other day was that the diagonals of a rectangle are congruent. All the rules of rhombuses come into play. So each of the diagonals is a perpendicular bisector of the other. So all the internal angles formed by the diagonals intersecting. So if I were to do this, and I know this is not well drawn, and this, I'm going to end up with right angles all in here. Okay. In addition, I'm going to end up with this situation right here. Okay, so how many congruent isosceles right triangles do we have formed? We got four. So in the family of parallelograms, which is in the big family of quadrilaterals, within this family, okay, so that's the big oval, you have a family of things called rectangles, and you have a family of things called rhombuses. And inside of those, in this shared area right here, that's where we find squares. This is called a Venn. Oh, let's try that again. Venn diagram. It's just a way of putting things in classifications. You probably did this in biology class. You got mammals, and inside the mammal family, you got the bovines and the canines and the, primates. Okay, and then within that, you got different species within those groups, right? So that's the same idea. This is weird. All right, conditions of rhombuses and squares. So we talked about this. If the diagonals of a parallelogram are perpendicular, the parallelogram is a rhombus. Okay, that was a weird slide. Didn't really work real well. To fix that, when I get around to it. get it, round to it. Okay. One diagonal of a parallelogram bisects a pair of opposite angles, and the parallelogram is a rhombus. So if I have a scenario where the diagonals are bisecting angles and we see stuff like this, I've got this, and this is congruent to this, and these are congruent here, I have a rhombus. Okay, now one of the other ways of doing this is if you get one pair of consecutive sides congruent of a parallelogram. Because as soon as I have that, because the rule is what? If I have a drawing like this, I tell you it's a parallelogram, now we know that because opposite sides are congruent, so now I would end up with this, and look at this. I got 1, 2, 3, 4, all four sides are congruent. Therefore, I have a rhombus. Last but not least, if a quadrilateral is both a rectangle and a rhombus, then it is a square. Don't forget this. Fun visiting with you guys. We should have a homework quiz again tomorrow on this material. So check Google Classroom for the assignment, and stay healthy.